This video will look at how to solve a system of equations using augmented matrices. And in this example, we are solving the system that you see here. That is x plus 3y plus 2z equals negative 5, 2x plus y plus z equals negative 6, and negative 4x minus 13y minus 5z equals 10. We are going to solve this by using one equation to eliminate variables from the other two equations. The very first example that we're going to use is I'm going to clear out the 2x in the second equation. I'm going to clear out that 2x using the first equation as I figure out the undo redo part of this software. There we go. So now I'm going to multiply negative 2 times the first row. By the way, the first row refers to the first equation that you see here. I'm going to take negative 2 times the first row and add that to the second row. So row 2 refers to the second equation that you see here. That's going to become my new second row. Throughout this, I'm going to use uppercase R sub 2 to indicate the new second row, and lowercase to always refer to the current second row. So if I take negative 2 times the first row, that's going to give me negative 2x minus 6y minus 4z equals positive 10. And that refers to negative 2 times the first row. I am now going to copy the second row over. That's 2x plus y plus z equals negative 6. And I'm going to add those two together. And when I add, the negative 2x plus the 2x cancels out. I don't have anything there. The negative 6y plus y gives me negative 5y. And I probably shouldn't have put that minus there, so let's get rid of that. And then finally, negative 4z plus z gives me negative 3z. And now finally, 10 minus 6 gives me 4. So that will be my new second equation. So I'm showing you the long way. What I would be doing in theory at this next stage, I'm showing how the long way works. We're going to have a short version of this. Is I would copy the entire original system over again, but using a new row 2. Row 1 is going to stay exactly the same. So here I am copying this original system over again. So I have x plus 3y plus 2z equals negative 5. And the new second row becomes this equation negative 5y minus 3z equals 4. Notice I'm careful to line up the x's with the x's, the y's with the y's, and the z's with the z's. And the fourth equation stays exactly the same, minus 4x minus 13y minus 5z equals 10. And so that would be the first stage of the process. That is kind of a long process, so the rest of this is showing you how we can have a shortened version of it. During this first worked example, it might not seem that short because I'm explaining as I go, but once you actually get used to the process, it'll be a lot faster. So we are going to use an augmented matrix in order to be able to work this. So the augmented matrix form for this would originally be, so if I copy the original system in its augmented form, I put a square bracket for matrices. 1, 3, 2, negative 5 refers to the coefficients and numbers in the first equation. 2, 1, 1, negative 6 for the second equation, and negative 4, negative 13, negative 5, and finally 10 for the third equation. I draw a vertical line here to separate the left-hand side of the equal signs in these equations from the right-hand side. And so what I've done in this very first step is I have shown that I have an equivalent system equal to the first row becomes 1, 3, 2, negative 5. So this is what I'm doing. I'm using the second version, 1, 3, 2, negative 5. 0, negative 5, negative 3, 4. And then the third equation would be negative 4, negative 13, negative 5, and 10, square that out. And so the little twiddle symbol that you see between the two is showing these systems are equivalent. I'm not going to write equals because the matrices don't equal each other, but they're equivalent. They refer to the same system overall. So that would be how this process would look in long form. But what we're going to do is solve this whole system directly in augmented matrix form and not write the x, y, and z at all. So I'm going to have a complete restart. Be patient. I'm going to start the whole thing over again with the original system in its augmented matrix form and show how this first couple of steps that we did can be done a lot faster. So we're going to start over using only augmented matrices. So first I'll copy down the augmented matrix for the original system. So that's 1, 3, 2, negative 5, 2, 1, 1, negative 6, negative 4, negative 13, negative 5, and 10 with a vertical line. And let's get going. So what I'm doing here is I'm taking negative 2 times row 1. There's row 1, row 2, row 3. Negative 2 times row 1, and I'm adding that to row 2 to create my new row 2. So row 1 is going to stay exactly the same. It's not going to change, so I'm just going to copy it down right here. Excuse me. Drawing that vertical line. And if I take negative 2 times row 1, that's going to give me the numbers negative 2, negative 6, negative 4, and positive 10. And then I'm going to copy row 2, 2, 1, 1, negative 6, and I'm going to add them up. So that gives me 0, negative 5, negative 3, and 4, and that's my new second row. I'm just going to copy that down right there. 0, negative 5, negative 3, and 4. And now I'm going to try and clear out that negative 4 in the lower left-hand corner of the original augmented matrix. I'm going to do that by taking positive 4 times row 1 and adding that to row 3. And I'm going to do scratch work on the right-hand side of the screen to show that exactly the way I did earlier. So I'll have negative 4, negative 12, negative 8, oops, positive 4, positive 12, that's a positive 4 I'm using, positive 8, and negative 20 as 4 times row 1. And then I'm going to copy row 3 exactly as it stands, negative 4, negative 13, negative 5, and 10, then add them up. That gives me a 0, a negative 1, a 3, and a negative 10. And that's my new row 3. 0, negative 1, 3, negative 10. So I've completed the first stage of the process here. I've used the first row to clear out the spots below, so that now reads 1, 0, 0. I'm clearing out some of that scratch work because I think I'm going to be needing that space in a little bit. You can always rewind and see that scratch work again if you want to take another look at it. But now I begin the next phase of the process. I originally used that 1, see that box I drew around the 1, as the pivot to clear out the clear out the 2 and the negative 4. So that 1 in the upper left-hand corner was my original pivot. Now, that spot where I have a negative 5 is where that's the position I'm going to use as the next pivot. I just do not like having the number negative 5 there. It was really helpful that I had a 1 in my original pivot position, so I want this to be the number 1. And so we think about, how could I get the number 1 there? Well, one of the easiest ways I can do that is just swap row 2 and row 3. And so that's what I'm doing right here. The first row will stay exactly the same, 1, 3, 2, negative 5. And the new second row will be 0, negative 1, 3, negative 10. That was the third row. And my new third row, 0, negative 5, negative 3, and 4. So I'm getting closer. Instead of having -5 in that spot, I now have -1 in that spot, but I want +1 to be the pivot position in row 2. So in order to make that happen, I'm going to basically multiply by row 2 by -1 to create my new row 2. So row 1 stays the same. My new row 2 just changes all the signs. 0, 1, -3, +10. And row 3 will stay exactly the same. And so if we take a look at where we started, we are now working our way through the process. We used 1 as the pivot. Now I finally have a 1 in that pivot position in the middle of the second row. And that is what I'm going to use to clear out the 3 above that 1 and the -5 below that 1. So just recapping where we started out, we swapped, we reversed, and now, as I said, we finally have a 1 as the pivot in that position. So the next stage in the process will be, let's take -3 times row 2 and add that to row 1 in order to take that 3 away from row 1. So again, lowercase r1 is the current row 1, r2, r3, current row 2, current row 3. -3r2 plus r1 is going to be the new r1. Row 2 will stay the same. And we will figure out in a minute what happens with that -5. So at this stage in the process, let's figure out where I am. Row 2 is going to stay exactly the same, 0, 1, -3, 10. And let's do some scratch work to figure out the new row 1. I'm using this equation I've just circled, -3r2. So -3r2, I'm just taking the numbers in r2 and multiplying them times -3. So I have 0, -3, +9, and -30. And that's -3r2. Row 1 is what I'm writing right now. I've got 1, 3, 2, -5, and I'm going to add them up. And so my new version of row 1 is going to be 1, 0, 11, -35. And so that's what I'm going to copy as my new row 1. 1, 0, 11, -35. So now, in order to clear that -5 from the middle of the third row, I'm going to take +5 times my pivot row and add row 3. That'll be my new row 3. So let's show the scratch work for that. So when I take 5 times row 2, that's going to give me 0, 5, -15, 50. And the current row 3 is 0, -5, -3, and 4. And I'll add them up. And I get the nice advantage that I get 0, 0, -18, and 54. The advantage being I have 0 in that second position of row 3. So if you look at the columns, column 1 now reads 1, 0, 0. Column 2 reads 0, 1, 0. What I'm doing is I'm making progress. I'm filtering this equation down using this relationship. So my next phase in the process is, after using the 1 as a pivot to clear out the -2 and the -4, and the +2 and the -4 in the original, then using the 1 pivot that I finally created to clear away the 3 and the -5. So there's the 1 pivot I created to clear away the 3 and the -5. I'm now looking for a pivot in my new spot, which is where the -18 is sitting. I would like that to be the number 1 in that pivot position. The easiest way to get that is just divide everything through by -18 on that third row. So as I'm writing here, I will divide by negative 18. That means everything gets divided by negative 18. So the zeros over negative 18, the next zeros over negative 18, the negative 18s over negative 18, and same with the 54. That's the only change I'm making at this stage. So let's copy the first row over again as is, and copy the second row over again as is, no changes. But now the new third row will be what I get after dividing by negative 18, which would be 0, 0, 1. 54 over negative 18 works out to be a nice clean negative 3. So again, lowercase r1, r2, r3 refer to my current rows, and I'm going to use that 1 in that position on row 3, near the end of row 3, as my pivot to clear out the 11 and the negative 3. To do that, I'll take negative 11 times row 3 and add that to row 1, and I'll also take 3 times row 3 and add that to row 2. That's going to clear out the 11 and the negative 3. Let's do the scratch work on that. So when I take negative 11, well, let's copy negative 11 times row 3 is 0, 0, negative 11, and positive 33. And the current row 1 is 1, 0, 11, negative 35. So when I add these together, those 11s cancel, and I have 1, 0, 0, negative 2. And that is going to be my new row 1, 1, 0, 0, negative 2. Let's figure out my new row. Row 3 is going to stay exactly the same. And so I have 0, 0, 1, negative 3. And so the one thing I don't have at this stage is I need a new version of row 2. So I'm going to use 3r3 plus r2 to come up with a new row 2. Let's do the scratch work. 3r3 becomes, there's r3, that's what I'm tripling, becomes 0, 0, 3, negative 9. R2, as it stands, is 0, 1, negative 3, 10. And let's add them up. So I'm going to get 0, 1, 0, and 1. And so that's my new row 2. This largely completes the process, and it may not be clear, but we have a system now that says 1x plus 0y plus 0z equals negative 2, 0x plus 1y plus 0z equals 1, and 0x plus 0y plus 1z equals negative 3. In other words, what this says is that x equals negative 2, and that y equals 1, and z equals negative 3. And that is the solution to the system of equations. So we've gone through this process, starting with the original system at the very start, and using augmented matrices, we have added various equations together in an organized way using augmented matrices. We have gone through the process of pivoting in the upper left-hand corner. And then we went through and used multiples of that first pivot row added to the second and third rows to clear out zeros. We then pivoted off the second position in row 2 by creating that as a 1, so it's a more useful pivot, and used that to clear out above and below. And finally, we had the negative 18 spot as the pivot position. We wanted that to be a 1, and we could use that 1 as a pivot to clear out the 11 and the negative 3. And that is how we ended up with rows that said x plus 0. The first row just says x, the second row just says y, the third row just says z, and that is how we came up with our solution. And it also helps motivate why we wanted the pivots we did. The fancy name for this is called Gauss-Jordan elimination. This is something Gauss had worked on, and a later mathematician named Jordan came and kind of cleaned it up and formalized it, and that's the name of this process, Gauss-Jordan elimination. The name for this final form that we have with all the ones and zeros is called the reduced row echelon form of a matrix. And that's going to be handy at several spots as we work through the remainder of the course. There we are.